Alright, so the last stage of this whole thing is to try to tie what we've learned, a little bit at least, into the real world. So here I am in the real world, watching the cars and the trucks and the buses go by. And I started thinking about it, and I figured that at a busy intersection like this, there must be a lot of these things going by. Now let's say that in the course of a normal day, 5,600 vehicles go by all day. So that's cars, trucks, and buses. Let's say that there are 3 times as many cars as there are trucks. And then, if you add up the number of trucks and 3 times the number of buses, it's equal to the number of cars that go by. Right? So we're going to try to tie that together. There goes a bus. And use matrices and a matrix equation and inverse matrix to figure out how many cars, how many trucks, and how many buses go by here in one day. Alright, so the first step is going to be to try to turn these into equations, these crazy things that I told you. So you should try to do that now. Alright, so what equations did you come up with? Well, here's what I got. If the total number of vehicles coming through is 5,600, and I represent the number of cars by C, trucks by T, and buses by B, then I could write an equation like that. If the number of cars is 3 times the number of trucks, well then we could write that down, right? But we're going to have to turn that into an equation that'll lend itself to being a matrix equation, or part of a matrix equation. So remember what I said was that we need everything to be, all the variables to be on one side. So we'll have to subtract the 3t over to be on the side with the c. So c minus 3t equals 0. So that'll be a better way to use that equation. That's the same. It's an equivalent equation. It's just in a more standard form. And then the last one, the number of trucks plus 3 times the number of buses is equal to the number of cars. Okay, that's how that would look directly from what I said. But again, we should rearrange it so that everything's on the same side. I'm going to choose to put everything on the side with the C, to leave the C positive. You could put everything on the other side. That would also work. So I get C minus T minus 3B equals 0. And I have 3 equations. I've translated the English into the math. Now I need to translate that math into some matrix math. Do you remember how to do that? How am I going to take those 3 equations and make a matrix equation out of them? It's a little bit weird because there's a lot of zeros running around. Try to do that now and see if you can get the same thing that I get. Alright, so this is what I came up with. What did you get? Is it similar to this? Now there are alternatives that would work as well, but if we use the equations that I've got boxed up there in the way that I've got them written, then this is the matrix equation that's equivalent to that. Okay? So now, what do we have to do next? We want to find C, T, and B, right? We're going to use our calculator, but what is it that we're going to do? Right, we're going to have to find the inverse of this coefficient matrix. Okay? Wow, the wind is blowing my screen around. That's why you might be getting some motion sickness right now. It's a really windy day. So you might want to start off by just finding the determinant of this matrix to make sure that it's not singular, to make sure that we can find the inverse. You don't have to do that. You could jump straight into finding the inverse, but just for fun, what do you get for the determinant? I haven't taught you how to find determinants of anything but a 2x2, so you can't do that by hand. I'm going to call that matrix A, and I get a determinant of 14. Alright? Make sure that you know how to do that on your calculator. So then, when you find the inverse, again using your calculator, what do you get? And try to put it into frac mode so that it's not sort of terrible decimals. Alright? Remember that the way that that kid did it in that video I uploaded? Right? Try to use that frac button to put it in frac mode. Alright. Wow, it is just crazy windy today. Alright, so did you get an inverse matrix like that? Right? If you put it into frac mode, it's all over 14 because of that determinant of 14. Some of mine are over 7 because I guess they reduced it, right? The calculator reduced that from 2/14 to 1/7, etc. Anyway, yours should look something like that. Alright? So then, as usual, to find the variable matrix, in this case CTB, we're going to multiply that inverse matrix times this thing, right? In previous examples we called that matrix C. So we're going to multiply the inverse matrix times that. Alright, so try that. When you do, even if you're using the decimal versions of the matrix elements, you should get these nice answers. 3,600 cars, 1,200 trucks, and 800 buses. Okay, so we've solved a sort of real problem using matrices. And no matter how complicated it gets, well, within reason, you can 7 equations and 7 unknowns, 10 equations and 10 unknowns using this technique. It's very powerful and very quick with your calculator. So you're welcome. Alright, try to work on those problems I assigned in the last part, and I'll see you next week.